In this video, I will be using Desmos for logs and exponents. So my first example asked me to evaluate log base 4 of 64. So I'm going to go on over to Desmos, type in log. And in order to get my base, I'm going to press Shift and then the underscore button, type in 4, arrow to the right. And then I like to use parentheses. You don't have to in all cases. So once you put the parentheses there, even before I finish, you notice that 3 pops up. So what this is saying is 4 raised to the third power is 64. So you just evaluated your first log. All right, so this is 3. And now the next examples will be to take those functions that are shown and determine whether or not it's going to be an exponential growth or decay. And as I'm typing it in, it's going to automatically graph for me. I don't need to enter the f of x portion. So what I want to do is go ahead and X this out, put parentheses 1. Once I put my slash in, it's going to automatically give me my fraction. Arrow over to finish your parentheses. Otherwise, it's going to put the parentheses in the denominator. And then I want to do Shift 6, which is my caret symbol, and that gives me my exponent. So you'll notice it automatically graphed for me. All I have to do now is just click on the point that I want. So I want the y-intercept. The y-intercept is where x is 0 and it crosses your y-axis. So in this graph, when x is 0, y is 1. So you want to write it as coordinates because that's what it is. 0, 1 is a point. My x-intercept, however, in this graph does not exist because I have what's called an horizontal asymptote. So when I'm talking exponential functions, it's going to be a horizontal asymptote. If I'm talking a log function, it's a vertical asymptote. What does that mean? That means horizontally, I would have a dashed line where it's at 0 in this graph. So I will go back over and I'm going to write for my x-intercept, there is not one, but my asymptote is y equals 0. Make sure that you identify whether or not it's y equals or x equals. And again, that's based off of exponential or log. So the next one, I am going to go back and delete what's shown. And I had 0.5 times 3. Again, if I hit the backslash, it's automatically going to give me the fraction, arrow over to the right. And now I want to raise this up by hitting Shift 6 to the x power, right arrow over to make the number big again. And it was -1. And now once I look at my graph for my y-intercept, if I click on the point that's on my y-axis, it shows me where x is 0, the y-intercept is -0.5. So I'm going to go ahead and notate that. When x is 0, y is -0.5. And let's see if we have an x-intercept this time. Yes, we do. So if we click here, we see when y is 0, x is 1.71. Now our asymptote, again, is a horizontal asymptote for both of these. Okay, and this one, I see that if I am tracing like the horizontal part, horizontal means left and right, it's going towards -1, but it never touches it. Even though it looks like it's touching it, it really isn't. My asymptote is going to be y equals -1 for this graph. Now, sometimes you'll have instructions that ask you to condense and simplify. So you would just go over to your calculator. So log base 3 of 9. Okay, now be careful here. See how it's still blinking by the 3? If you don't arrow over to the right, it's going to just continue making the number small. So 81 is going to be big, and then we want plus log base 3, arrow over. So we'll have a big 9, and then as you can see, it automatically tells you that the answer is 6, and that is correct. So for this one, it's 6. When you see the word solve, please make sure you go back and check for extraneous solutions. Also, the good thing about Desmos is when you see this equal sign, all you have to do is set it up in 2 different lines or 2 different rows on Desmos, and it will show you at the point of intersection what your x value should be. All right, so I'm going to go ahead and type in this first row, 3 raised to the x power. So again, Shift number 6. And now I want to go to the second row and type in not just 1/27 because it's set equal to each other. Because you see an equal sign, you can't just put this number here because it won't always cooperate. So you want to put y equals this number. So y equals 1. Once I hit the slash, it'll automatically allow me to do the fraction. And you'll see here, it's showing not only the line, because you can barely see that line, it's showing what 1/27 is as a decimal. So I'm looking at where y is going to be that amount or that value, and this is what my x will be. So the answer for this problem is actually just the x portion, which is -3. And if I were to substitute that back in, because you should always do that, what I would do is just simply copy this, or I don't even have to copy it. I can just over that x. So I want to shift 6, -3, and now you see that they actually match. So that's what you're looking for when you're checking your extraneous solutions. You're substituting the x portion, not what they said y was, even though it happens to be the same thing. All right, so now let's move on to this one. I have log of 16x, and then I'm going to subtract it from log of 4, and it's supposed to equal 2. So again, I don't want to just put 2. I want to put y equals 2. And I will notice that 2 graphs populate. And I can look at the color. So the green one is the log one, and then the purple one is the one for y, which is going to be horizontal. What I'm looking for is where they actually intersect. So where y is 2, where do they intersect? So it's somewhere in here, it looks like. So when y is 2, x is 25. You are looking for the x value. So I'm going to highlight this, and I'm going to replace it in parentheses with 25 because that's what we said it was. And yes, y is 2. So 25 is the correct answer. That's how you solve for these type problems. So x is 25 when y is 2. All right, so we're going to go to the next one. This time our base is x. So we're going to type in log shift underscore x, arrow to the right, and 25 is going to be in parentheses. And then I'm going to go to the next row and I'm going to type y equals 2. So when y equals 2, what is x? So I want to see where they actually intersect. And if I come back this way, I can see right here, when y is 2, x is 5. So I just want to test it, check my extraneous solutions, and yes, they equal. So I know it's 5. All right, for this next example, what I like to do is just use my power product, which means I'm going to take my exponent 3 and I'm going to move it out front and then put it in Desmos that way. So that would look like 3 log base 4 of, and I'm going to move this arrow over, x minus 1, and I'm not raising it to a power because remember I moved it out front. And then I'm going to set the second row equal to y, so y is equal to 9, and I will look over at my graph to see where they actually intersect. If I keep going, I see blue is my y, and then red is my log graph, and they seem to intersect right around here. If I keep clicking, Desmos will actually show me. So y is going to be 9 when x is 65. So let's go ahead and test it out. We put 65 there. Yes, they both equal 9. So that's my answer for that one. And now if I go to the natural log one, it's the same concept, but I'm just using natural log. So I type in ln 5 and it was plus natural log x, and it was set equal to 1. Y equals 1. And now I'm going to look at the green and the purple graphs where they intersect. And I see that if I click on it, that when y is 1, x is going to be 0.544. So let's test that. 0.544. And yes, it's approximately 1. So that one is going to be e raised to the, again, shift 6, natural log x to the third. So we have to do the shift 6 again. Going to the next row, we're going to type in y equals 8, and we're going to see where the two graphs intersect. And when y is 8, your x value is 2. So let's go here. Okay, there we go. And we see that both match. So that's right. We're going to change that to 2. And you probably had figured that out anyway manually, because basically if you have the same base for the exponent and your natural log or log, you can just cross that out and you're left with x cubed is equal to 8. And in order to get rid of that cube, you can do the cube root on both sides, and x would equal, matter of fact, let me show you that too while I'm here. If I wanted the cube root, instead of having to go all the way to the functions, like going under my keyboard and going to functions to find it, I could literally just type in int root, and then it allows me to put the 3 there. So 3, and then I want to put 8, I should end up with the answer 2, which is what we said that x was going to be. So that's if you manually solved it. So you'll still end up with the same answer, which is 2. All right, so the last example, I'm going to type in 2 natural log x minus 2, and it's set equal to 0. So again, y equals 0. And I see where the purple and the green intersect. It says when y is 0, that x is 2.718. Now, if you recognize this number, it's kind of like pi is 3.1415, so on and so forth. You should recognize this actually is the value for e. So for your x value, you could either go ahead and write that 2.718, or you can simply say e, because it means the same thing. All right, that's it for the video. Like and subscribe. Have an awesome day.